All right. So I hope I'm visible to all of you. So hello everyone. I hope you all are doing fine. Okay. So we are again live again with a new content, and today we will be starting with vectors. Okay. So we'll discuss the previous year problems from vectors, and with this we'll also clear some of our common misunderstandings and doubts regarding vectors that you are actually having, right? This is a very simple chapter. Okay, so I can guarantee you, if you are watching this particular part and you are staying with me and solving the questions, I can guarantee you that you can definitely score the full marks in vectors and 3D geometry part. Okay, so kindly follow the vectors part nicely so that you can have a continuation in the 3D geometry. Okay, because these two parts are very correlated to each other. Okay, so I'm starting this part of vectors now, and in the next part we will basically start with the 3D geometry. Okay, so we'll have two more live classes regarding this. Okay, all right, so I hope I'm visible to all of you. Kindly give a thumbs up. All right, so okay, so I guess I am audible and visible to all of you. So we will discuss with the CBSE 2000 CBSE previous year problems on the topic of vectors. Okay, and I will be the instructor for this particular course, and my name is Sirsha. Okay, so let's get started on this particular thing. Okay, and our goal is today to discuss about the vectors and 3D geometry part. Initially we'll start with the vectors part, and we will move to the 3D geometry part in the next upcoming lectures. Okay, so our main focus will be on the vectors part right now, but since we are doing the both the things simultaneously, it will be beneficial to students who are basically following this part. I will be giving you ideas about 3D geometry, and from 3D geometry how you can solve vectors or the combination of both, right? So it's a simple chapter. You just need your visualization and understanding, right? Next we go on to understand the direction ratios and direction cosines. Okay, now this is something that many students are very confused about. So in today's lecture I have taken some questions where I will show you that how easy these topics are. Okay, and these are nothing but just a unit vectors. Okay, then we also understand about how to apply the ideas of vectors to visualize the 3D geometry part, and with that we will also see about the techniques that are useful for solving different types of problems. Okay, along with that we will also see the what is the exam type pattern questions that are basically expected, and you can also we will also do some paper analysis after this. Okay, so with this previous year problems we will also do some paper analysis so as to understand like what are the different sets of problems that can be asked in the paper. Okay, so with this let's move on to the very first problem. Okay, so anyone who is basically watching this particular part right now, I would all request you to just try to solve this part on your own. Try to read this. So this is a question from 2024 paper. Okay, very simple one marker problem. It's an MCQ type problem. Okay, so again I'm repeating that in CBSE examination the most crucial thing to get a good marks or a full marks is basically your the way you approach or write your solutions. Okay, so the better way you express your write your solution, the more better marks you're going to get, right? So that is something that you need to keep it in mind. Okay, so whenever you have a one marker problem also, don't forget to clearly express and write all the parts. Okay, so it said that we have two vectors, a vector and b vector. Now these are two unit vectors. Okay, so I are given as unit vectors over here. Okay, and theta is the angle between two vectors. Theta is the angle between two vectors. Okay, so we have a vector and b vector as unit vector, so mod of that or modulus value of that is basically equal to 1, right? Then we have also provided the information that is sine theta is basically equal to 3 by 5, right? So we have information about sine theta. Now we need to find out what is the dot product of a cap dot b cap. So a cap dot b cap is basically given as mod of a cap into mod of b cap into cos of theta, right? But I have information about sine theta, right? Now you know by trigonometry the very famous identity that is sine square theta plus cos square theta is equal to 1. So from here you'll get cos of theta is basically square root of 1 minus 3 by 5 whole square. So this can be simplified and it is basically equal to, so this you can do it by yourself, and this will get as 5 upon 4 upon 5, right? 4 upon 5. So you will get cos theta as 4 upon 5. So with this dot product of a cap dot b cap is going to be equal to 4 upon 5. As simple as that, right? Very simple, straightforward, one another problem. So the answer to this particular problem is going to be equal to 4 upon 5. Got it? Very simple, straightforward problem. So we started with a very simple one marker problem that was actually asked in the paper 2024. Okay, so you can see these problems are neither difficult. The thing is that you have to apply your basic concepts. Okay, so we applied a trigonometric identities and we applied the concept of dot product, and that's how we got the answer. So this is a one marker problem. So if you do this particular part step by step and you explain the answer in this manner and you mark the answer correctly with the given option, so you are going to get the full marks, that is +1. Okay, I hope this particular thing is clear, right? Please give some thumbs up if it is clear. I'm waiting for your confirmation. You can let me know if you have any queries. Vectors and 3D is very easy as well as very high scoring chapter. Okay, so please prioritize this chapter as your most important and favorite chapters. Okay, among those favorite chapters. Okay, because this will actually help you to fetch a lot of marks. Okay, and you will see that there are a lot of questions that are basically coming up in the previous year paper also. So with that you can at least guess that this chapter is really important. Okay, so with this let's move to the next problem. And another problem we have is a very simple problem on the definitions of vectors. Okay, another one marker problem or a MCQ problem. Okay, so again, how do we approach or write this problem? Okay, so first of all, given thing is basically we have the terminal point. Now many students who are basically don't know the basic nomenclature of the vectors, I will repeat that for them. So we have the given terminal point as a, that is 2 comma minus 3 comma 5, and the initial point as b, which is given as 3 comma minus 4 comma 7, right? So we have the terminal point and the initial point given as the follows, right? Now for students who don't recall the definitions of the nomenclatures of vectors, so in a vector is basically starting from a initial point. Okay, so it is starting from an initial point. So in this case we have the initial point as point B, and it goes to a terminal point, that is a point where it ends. Okay, that is called the terminal point, right? So this is how we represent a vector. Okay, so the vector is directed towards B to A. Okay, so it is directed towards B to A. So therefore we represent this vector as BA vector, right? So it is terminating at A and it's starting at B. Okay, so that's how we represent a vector, right? Now how do we find out that what is this particular vector given we have the information about the 3D coordinate of the points? Okay, so once you know this particular terminal point information, let us now try to understand by a simple 2D case. Okay, so in 2D, if we represent 2 points in a 2D coordinate space, so let us say we have a point A as x1 comma y1 and we have the point B as x2 comma y2, right? So if we have this particular information about A and point B, let us try to understand what is the concept of a origin. Okay, so this is basically the origin, right? So what is the concept of a position vector is that, so if we join the origin to the point of any point on the coordinate space, we get a position vector. So in this case we have the position vector as A vector. Okay, so I will also represent this by small letter A vector. Okay, and similarly if I join the origin to the point B, we get another position vector, that is OB, and that is basically position vector B, right? So we represent that by small b. Right, now if we recall, so if I recall from the triangle law of vector addition, okay, so I'm writing over here triangle law of vector addition. So from triangle law of vector addition we get, so over here what we can see that we can write OA vector plus AB vector is basically equal to OB vector, right? So we know this by the simple triangle law of vector addition. So from here I can easily find out what is the AB vector is basically equal to B vector minus A vector, right? So what is B vector and what is A vector is nothing but these are the position vector with respect to the origin, right? So what we can write B vector as, so B vector can be simply written as x2 I cap plus y2 j cap, right? x2 I cap plus y2 j cap, right? And similarly I can write the position vector A as x1 I cap plus y1 j cap, right? So any position vector with a given point can be easily written as in terms of x, y and j, right? X, y and z, sorry. So in 3D space, I will have one more coordinate, but I'm explaining with reference to the 2D space, right? Now, similarly, in 3D also, in order to find out the vector connecting the 2 points or 2 points in the 3D space, we just need to take the difference of the given position vectors, right? So I'm erasing this part of the solution. I hope it is clear to all of you, right? So we'll do the same thing over here. So from here, let us continue. So therefore, with a given point A and B, if we need to join the vector BA, so our BA vector will therefore be equal to the small b vector, sorry, small a vector minus small b vector, right? So what is small a, small b vector? A vector, the position vector of A is given as small a vector and the position vector of B is given as small b vector, right? And we can easily write this A vector as 2i cap minus 3j cap plus 5k cap, and similarly the small b vector as 3i cap minus 4j cap plus 7k cap, right? So this is how we represent the position vectors, right? So from here I will just get the BA vector as simply as, so by subtraction of these two vectors, okay? Right. So if we just simply perform this operation, we are going to get minus I cap plus j cap and minus of 2k cap, right? So if we just look at the option, it is option number D, right? So from here, which is what the correct answer to this problem is that with a given terminal point and the initial point, this is the required vector we need, right? So we have the given answer as option number D, right? So D is your correct answer. So person who have got D, congratulations, you got it, +1. Okay, so this is a 1 marker problem. So if you are solving this problem by writing all the given informations and you're doing it properly, you're definitely going to catch the full marks, right? You don't need to show the calculation of the triangle law of vector addition, and what I did, it was just to prove that how does it comes out. Okay, so some people who don't remember it or don't recall it, I can help all of you, okay, so that you can revise it, okay, with this particular questions. Okay, so I hope this question was simple and clear enough. Please give me a thumbs up if it is. Please let me know in the comment section or chats. Is it clear to all of you? Right. So this part is clear and simple, right? So let us move to the next part then. Again, we have one more problem. Now this is a 2 marker problem, okay, from the 2024 paper. So these are 2 marks problem, okay. So now let us see how we can solve this problem, okay. So solving this problem, so let us first of all read the problem what is mentioned. So we have two vectors, a vector and b vector are the two non-zero vectors, right? So I will write it over here. Given two non-zero vectors, okay, given two non-zero vectors as a vector and b vector, right? Now also given information of that, we have a vector plus b vector is basically perpendicular to a vector, and also we have information about 2 times of a vector plus b vector is perpendicular to b vector, right? So we have these two particular information about the vectors, right? So we have two non-zero vectors a and b with a given following information, right? With a given information as a plus b vector is perpendicular to a vector and 2a plus b vector is basically perpendicular to b vector, right? So on the given information, let us now try to understand that what is the concept of perpendicular vectors, right? So from our basic knowledge of the dot product, we know that a dot b is basically given as modulus of a into modulus of b into cosine of theta, right? Where theta is the angle between the vectors, right? So angle between vectors, right? So with this particular information, so if this angle is pi by 2 or 90 degree, right? So if these vectors are perpendicular, then this angle between the vectors are going to be pi by 2 or 90 degree, right? So if it is 90 degree, then cos of theta is 1, cos of theta is 0, sorry, cos of theta is 0. So therefore we will have a dot b is basically equal to 0, right? So for perpendicular vectors, we just need to put a dot b as 0, right? Similarly from here, let us put this. So since a plus b vector is perpendicular to a vector, so therefore I will put a plus b dot a is equal to 0. That's my first equation. And similarly, I'll put 2 times of A plus B dot B is basically equal to 0, right? So we have two informations and two unknown vectors, right? Also, now we have to prove that, we just need to prove that mod of B is basically equal to square root times mod of A, right? That is what we need to prove over here, right? So now try to understand how do we basically solve this question. So first of all, in order to show the proof question, so first of all, please mention clearly that to prove this particular thing, right? So you just mention it to prove, and then you start your proof as writing as proof, okay? So you have to prove this. So please write it over here, to prove. Okay, this is to prove. Okay, so to prove this, and then you start your proof with writing proof, and then you write the statements as a given, right? Then now let us proceed from here. So if you just go on proceeding from here, I will get A dot A is basically mod of A square. A dot A is basically mod of A square plus A dot B is basically equal to 0. That's the first equation. Similarly, the second part we get basically 2 times of A dot B plus mod of B whole square is equal to 0. Mod of B whole square is equal to 0, right? So we have these two informations, and now let us use this particular information, that is A dot B is basically equal to minus of mod of A square. So if I just put it over here, I can just simply write it as 2 times of minus of mod of A square plus mod of B square is basically equal to 0. So from here I can simply write this as that 2 times of square root 2 times of mod of A is basically equal to mod of B, right? So that is our given relation that we need to prove. So after you get this particular part, so you just write it and mention as hence proved. Okay, hence proved, right? So this is how you have to basically solve this problem when it basically comes up in your examination. Okay, so please try to understand the process clearly. Okay, so these two proof questions or the proof that questions are very crucial for getting like understanding of it. Okay, so very simple problem, just you need to apply your fundamental concepts. Okay, and the way I'm approaching or writing the problem, please try to follow the same, okay, in order to get a full marks in a paper. Okay, I can guarantee you, if you're following these particular steps, you can definitely ace your exam easily. Okay, all right, so this is from my experience that I am basically giving all of you. Okay, so please try to maintain these things when you are basically coming up or writing your actual examinations. Okay, is it fine? I hope this is clear, right? Please give me a thumbs up if it is clear. Okay, all right, so I hope this part is clear enough and simple. If there is any difficulty, you can please tell me. Okay, let's proceed with the next problem. And again, you can see this problem was again asked in 2024 paper, right? So you can see there are a lot of problems that are basically asked from vectors. Okay, so there are 1 marker problem, 1 marker problem, 2 marker problem, and this was a 3 marker problem. Okay, this was a 3 marker problem that was asked in your CBSE 2024 paper. Okay, simple problem, just use your fundamental concepts of vectors. Okay, so again, I will show you how to write this problem. So whenever it comes out, so first of all, write given, we have the given information as, so in this particular information we have the information as A B C D is a parallelogram, okay, and please try to avoid short forms. Okay, while you are writing an actual examination, please try to avoid short forms. Okay, maybe I have seen more people who write parallelogram as parallel and GM. That is basically a short form of writing parallelogram, but please avoid this doing in an actual examination, right? So we have the information with a parallelogram ABCD with the given sides as vectors, as AB vector is given as 2i cap minus 4j cap plus 5k cap. Okay, also we have information about the dv vector as 3i cap minus 6j cap plus 2k cap, right? So we have this particular given information, right? Now we need to find out what is AD vector, right? So let us try to understand and plot this parallelogram that is basically mentioned in the problem. Again, please, while you are plotting this diagram of any questions in maths, please try to use a pencil. Okay, do not use a pen for drawing the diagram. This will actually, maybe if you are doing any mistake in that diagram, you have to cancel it out and you have to cut it down. That will basically destroy the decorum of the paper. Okay, so please try to have a pencil and an eraser with yourself while you are going for the actual examination. Okay, please maintain this. Okay, so we have the given notations as A, B, C and D as follows, and then this is our D vector. So I have one of the diagonal vector and I have information about the E vector, right? So I need to find out what is AD vector, right? So AD vector will be directed like this way, right? So AD vector is directed like this way. So let us say I need to find out what is AD vector, right? Now let us try to apply this in the triangle addition law, okay, in this triangle, in the triangle ABD, by triangle law of addition, triangle law of vector addition, by simply using triangle law of vector addition, what I can write? I can write AD vector plus DB vector is basically equal to AB vector, right? AD vector plus DB vector is basically equal to AB vector, right? That is what we can write by using simply the triangle law of vector addition, right? So if this is clear, please give me a thumbs up. Okay, so from here you can easily find what is AD vector. So what AD vector is basically equal to AB vector minus DB vector, right? So which we can easily simplify, and the process will be very simple, right? So AB vector minus DB vector is basically going to be equal to minus I cap, all right, minus I cap plus 2j cap, okay, and plus of 3k cap, right? So if you just simplify this or subtract these two vectors, you are just going to get minus I cap plus 2j cap plus 3k cap, right? So you have information about the AD vector, right? That is the first part of the calculations, right? So this we have found out AD vector, right? Now once we have found out what is AD vector, and we have information about the AB vector, right? So we have information about the adjacent side of a parallelogram. We have the information about the adjacent side of the parallelogram. Now, in order to find what is the area of the parallelogram ABCD, so let us see how we can find out the area of the parallelogram ABCD, right? So if you recall from your, so I'm erasing this part of the solution over here. So this diagram is drawn already. So if you just recall the area of a parallelogram, so if you just recall area of a parallelogram, please avoid using shortcuts. Okay, this will actually get you at least less step marks. Okay, so if you're writing all the steps clearly, then you are going to get a full marks for the steps. Okay, so area of the parallelogram can be simply written as mod of adjacent vectors cross product of it. Okay, and take the cross product of it. So we have the adjacent vectors as AB vector and AD vector. Okay, so these are the two adjacent vectors, and if you take the cross product and take the modulus of that, that is going to fetch you the right answer for the area of the parallelogram. So let us proceed with the performing this cross product. So I know how to perform the cross product is that by using the determinant, right? So we will write it over here, AB vector. Students who don't actually recall this, how to perform this cross product, please you can follow the NCERT textbook for this. Okay, and if you recall, please try to solve it quickly and tell me the answer you are getting. Okay, so from here, if I solve the cross product, let us try to erase this part of the solution. Okay, so proceeding further over here, I will get basically it is I cap times of minus 12 minus 10, that is going to be minus 22, right? Please let me know. This part is simple, right? I'm just looking at your query. Please let me know what are you getting over here. So it's minus 22 I cap. Then we perform with the j cap, minus of j cap times of, this is going to be 6 minus of 5, that's going to be 11, right? So minus 11 again, plus k cap times of, now this k cap times of 4 minus of minus 4, that is going to be 0, right? 4 minus 4, that is going to be 0, right? So we will have this cross product as minus 22 I cap plus 11 j cap, right? That is what we're going to have it over here, right? So now we try to find out what is the mod of this. So ultimate answer is going to be a mod of this, right? So we have to take the mod of the ultimate vector. So the answer is going to be over here square root of 22 square plus 11 square. And if we perform this calculation, you can perform this. Okay, so you can take 11 square as common. So then you will get basically as 2 square plus 11 square, right? So from here you can just simply solve it, and you will get it basically as square root of 605, and that is going to be equal to 11 square root of 5. Okay, so that is going to be the real answer to the particular problem. Okay, so you can just simplify this portion at your own. Okay, please let me know if you are having any query. Please let me know if you are having any query. And this solution is simple and straightforward, right? Okay, so this is going to be the area. So please don't write the area only as 11 root 5. Please try to write the entire answer, that is 11 root 5 square units, right? So whenever you're mentioning the area, please write it as 11 root 5 square units. Okay, so please mention this completely. If you're not writing the square units, maybe you can be making the examiner will deduct half marks. Okay, so if you're not writing square units, so examiner might deduct half marks. Okay, so why to deduct, or why to give a chance to deduct marks, right? So definitely mention everything clearly. Okay, this will actually help the examiner to process your paper, and it will show that you are a better candidate as compared to the other people. Okay, so I hope this is clear. Please let me know if it is clear or not. This is clear, right? Okay, so let us proceed with the further question. Okay, now I took this particular problem to revise a very interesting property, that is a sectional formula, right? So you must have studied the section formula in your geometry. So section formula in case of vectors. Okay, so we'll try to revise the section formula in case of geometry over here. So if we have a given vector with a given point A as vector A vector, and the B vector as given as small b vector, and I need to find a C vector with the vector notation as C vector is basically as over here, that is C vector times, so this is the origin over here, and if we just try to plot this position vector in the given notation over here, so if this point C is dividing this part AB in the ratio m is to n, then we can easily find this coordinate of point C vector in times of position vector C as basically m times of B vector plus n times of A vector divided by m plus n. Okay, so that is going to be a required answer for the position vector. Okay, so if we just try to apply this part over here, then we definitely get, so if we just try to apply this over here, so we will basically get the coordinate of the position vector C, right? So in this way we actually have to solve this problem, right? So let us try to understand what is the problem given over here. So we have a 2-point position vector, point P and point Q, right? And we are, the given position vector has this. So we have P and Q are the 2 points of the position vector, and the position vector of point P is given as 3a vector minus 2b vector, right? And the position vector of point Q is given as a vector plus of b vector, right? Now it is said that write the position vector of point R which divides the line segment P and Q in the ratio 2:1. Okay, so I need to find out the ratio of this particular point R as 2:1 times, right? So while we try to understand, now we'll just use a simple. So if we need to find out what is the position vector of R, so let us put the position vector of R as small r. Okay, so the small r over here is basically going to be 2 times of a plus b vector, that is the position vector of Q, plus 1 times of 3a vector minus of 2b vector divided by sum of this entire ratio, that is going to be 3, right? So if we just calculate or simplify this, we are going to get the position vector in terms of a vector and b vector, right? That is what is asked in the problem. So we can see this is basically equal to 5 times of a vector by 3, right? That is going to be a correct answer to the particular problem. Okay, so the position vector of point R, okay, so this is a point R, the position vector of point R is basically given as 5a vector by 3, right? So it's a simple problem. Okay, it's a 2-marker problem that you can expect to get in an examinations. Okay, so if you are solving this problem with the correct formula, so please don't forget to mention this section formula while you're writing an answer. Okay, so section formula, mention the section formula and then do the proceeding. Okay, so this will actually show that you know everything and you're doing proper correct steps. Okay, so if you're writing this answer in this way, you're definitely going to get the fetch the full marks, right? Is it clear? And also the thing is that this is the external division. Okay, so let me write it over here. So this is external division. So I solved it for the internal division. I'm very sorry. Okay, I solved for the internal division. All right, no problem. Let me solve for the external division then. So this is for the internal division. Okay, that is when the point C basically lies inside this line AB. Okay, so when the point C lies inside in the line AB, which is called as internal division, right? Now in case of external division, we just need to put this point m times of b vector minus n times of a vector divided by m minus n. Okay, as simple as that. So it is a case of external division. So our answer should be not be plus, so it should be rather minus. So please correct it up now. So over here this will be minus of it, right? So we'll have minus of a vector, and then we will, over here I will have plus of 4b vector, right, divided by 1, right? That is what we are going to have the answer to this particular problem. Got it? If you have any query, please tell me, let me know. Okay, since this division is given as external division, so we need to keep this in mind. Okay, this is external division. Okay, fine. So I hope this part is clear enough. Okay, so now in case of internal division, you have to use a plus sign over here, and in case of external division, you have to put the minus sign, because in external division, this point C basically lies outside this line segment AB. Okay, so here in this case, it is said that it lies on this particular side of B, because this length of it is 1 time and this particular length is 2 times. Okay, that's how the external division ratio is mentioned. Okay, do you have any query? Please mention. All right, so let's move further. I hope this part of the solution is clear enough, right? Okay, so this part is simple. Let's move to the next problem. So next problem we have with us is a simple problem, and let us say what it has to offer, right? So if we try to understand what the problem has to say, let us read the problem. So it says that given we have our a vector given as I cap plus j cap plus k cap, right? We have the given a vector as I cap plus b j cap plus k cap, right? And also we have the vector b which is given as 4I cap minus 2j cap plus of 3k cap, right? So we have this information about the a, b and c vector, right? And c vector is given as I cap minus 2j cap plus of k cap, right? So this is what we have provided with the information, right? Now it is said that we need to find a vector. We need to find a vector whose magnitude is 6 and it is parallel to the vector. Now, okay, so let me recall. Okay, whenever you need to find any vector which is parallel to a vector, so let us say we have to find an unknown vector x which is parallel to a given vector a. Okay, so the process is basically simple. So you just need to mention the what is the magnitude of the particular vector multiplied with the unit vector of the vector which is basically parallel to it. So x vector is parallel. So x is parallel to a vector. So we just need to multiply with the unit vector of a, or unit vector along the direction of a. Okay, that will just generate the vector which is parallel to a vector with the given modulus, okay, or the magnitude. So let us try to understand. It is parallel to the vector 2a minus of b plus of 3c. So if we just calculate this part out, so we just can calculate simple, right? This 2I cap plus 2j cap plus 2k cap, right, minus 4I cap minus 2j cap plus of 3k cap plus 3 times of I cap minus 2j cap plus of k cap, right? So we just simplify this part. This is going to be simple as equal to, this is going to be equal to I cap, this part is going to be equal to minus of 2j cap, okay, and the k cap part is going to be equal to, so 5 minus of 3, that is going to be plus of 2k cap. Okay, so you can simply solve this by your own. Okay, now if you try to find the modulus of this particular vector, this particular vector modulus is going to be equal to 9. So mod of 2a minus of b plus of 3c, modulus of that particular vector is going to be equal to 3. Okay, that's going to be equal to 3 units. Okay, so your unit vector is just going to be divided by 3, right? So if you recall the unit vector, so unit vector of any vector a is given as vector divided by the modulus of that particular vector, right? Fine. So now over here I just need to find a vector unknown. So unknown vector is basically going to be equal to 6 times, because it said that it has magnitude 6 times the unit vector along a 2a minus b plus 3c. So that is going to be equal to I cap minus 2j cap plus 2k cap divided by 3, right? So this is going to fetch me the information that is 2 times of I cap minus 4j cap plus of 4k cap, right? So simple and clear, right? So that is going to be an unknown vector x. Okay, so your answer to this particular problem will be like the unknown vector to the given problem is basically equal to this. Okay, so you can just check this particular vector will have a magnitude equals to 36, square root of 36, that is going to be equal to 6 units. Okay, so that's going to be a required answer. So please, again I am recalling. Okay, so whenever you need to mark the answer, please mark it in a box and put that the required answer is this. Okay, so that will actually show that you are basically doing properly and you're getting it full marks. Okay, so that will show that how well are you able to write the answer. Okay, so if you are doing this correctly, you will get basically +2. Okay, so this was a 2 marker problem. As simple as that. Okay, just need to operate this operation, and you just need to calculate the unit vector and just need to find the required vector like this. Okay, kindly let me know if you have any query. Okay, this part is simple, right? Very simple, right? So it is something like you have you have a vector like this way, and you need to find a vector with a given magnitude in the same direction, right? So it's a parallel, right? Now in case of anti-parallel, so if it is a vector is anti-parallel to it, we will just use the same unit vector but just with a minus sign. Okay, this is minus of that particular vector. Okay, and similarly this will plus of that. Okay, so if it is parallel, we just use the plus sign. If it is my anti-parallel or anti-parallel, which is mentioned in the problem, which is not mentioned in this particular problem, but if it is mentioned in any other problem, you can definitely use that particular notation just by simply using minus of a bar, a cap. Okay, so just in place of the unit vector, you just put a minus of a unit vector. Okay, that will actually suffice the entire problem. I hope it is clear, right? If you have any query, please let me know. Please let me know if you have any query. Okay, so I hope this part is simple and clear enough, right? Okay, so this is clear, and with this, let's move to the next problem. Again, we have a next problem, which is basically a problem of external division, right? And it is a problem where I had to basically prove that. Okay, and this was a 4-marker problem. Okay, this question was interesting in sense that it was asked in 2010 when there was higher order thinking skill questions were actually being asked. Okay, so you have to prove that something. Okay, over here, so it is a plus 4-mark problem. Okay, now how to approach this problem? Again, I have already shown you the process to approach this problem, right? So I actually want all of you to please approach this problem by yourself first of all, and then let me know whatever basically are you able to prove this result or not. Okay, take your time and tell me. Okay, so just take your time and let me know. So how to write this answer? Again, whenever you have a given prove that question, please write to prove. Okay, to prove at the beginning, so that the examiner is clear that your intention to prove the answer is basically clear, right? So that he doesn't have to look back, he or she doesn't need to look back into the question paper to check what is the question, right? That will actually create a trouble for the examiner, and the less amount of trouble you are putting to the examiner, the better marks you are going to score. Okay, that is what the something that you need to keep in mind. Okay, so these are all the strategies that you need to keep in mind while you're appearing for the CBSE examinations. Okay, so the given proof is basically that you have to prove that P is the midpoint is the midpoint of the line segment QR. Okay, is the midpoint of the line segment RQ. Okay, now let us try to understand what is this problem mentioned as. So it is mentioned that point P and point Q are given points with the position vector as 2a vector plus b vector, and point P is given as a vector minus 3 times of b vector as the position vector. Okay, now if I need to find out r vector, point R, which is basically, so it is said that find the position vector of point R which divides the line joining 2 points P and R whose position vector are given externally. Now it is again said it is dividing externally, right? So we just have to use the external division formula, and in the ratio 1:2. Okay, so if you just use a simple external division formula, so we can find out the position vector of R as, so we will just easily find it out as 1 times of position vector of Q, that is going to be this, minus 2 times of position vector of P, that is going to be 2a plus b vector, right? Divided by 1 minus 2. Now you can write this as minus of it. Okay, so doesn't matter over here. Okay, so we'll basically get it as this is going to be finally as minus of 3a vector, right? Minus of 3a vector and minus of 5b vector, right? Divided by minus 1. So your ultimate your b vector is r vector is going to come out as 3a vector plus b vector. Okay, 3a vector plus b vector, right? So once you understand this, now we have to show that point P is the midpoint of the segment RQ. Okay, so point P is basically the, so you have to just prove this opposite of it. Okay, so don't go by the drawing. Okay, maybe if you are drawing this part for the beginning of the problem, okay, there is not an issue. Okay, this will show that actually you have assumed something. Okay, now once you get to know that, you have to just put this part, so you can re-edit the diagram as like this. Okay, so this is the R point. Now you have to prove that point P is basically the midpoint of it, right? So we have the position vector of point A, right? We have the position vector of Q, we have the position vector of R. So we just need to use the midpoint formula. So the midpoint So midpoint is basically equal to r, position vector of r plus position vector of q divided by 2, right? So we just do this part on your own. So you can just see it is basically coming as 2a vector, right? 2a vector minus of b vector, right? Sorry, plus of b vector, right? Plus of b vector, right? So as simple as that. So that is going to be the equal to the position vector of point P. So that is a point P, right? So therefore you are able to prove that a given point P is basically the midpoint of the line segment RQ, right? Is it clear? Okay. So this is clear, right? Okay. So please let me know if you have any query in the comment section. You can definitely message that. Okay. Okay, so please follow the steps given as this problem. Okay, so once you write to proof, then you start with the proof. Okay, and while starting with the proof, please write the mentioned things. Okay, so write the given thing as this: the position vector of P and Q are given, and the external division ratio is given. Right, so those are the given statements. So please write the given at the beginning, then you start your solution. Okay, then you use the formula. So please don't forget to mention the section formula over here. Okay, so if you are mentioning the section formula, that will show that you are basically doing the problem from the real understanding. Okay, so that will give you the better step marks. Okay, so maybe if you're not able to get the answer correctly, but at least you will get a step marks on this. Okay, so that's something that you need to keep in mind. Got it? Right? Is it clear? Please let me know if it is clear. Okay, now I have an interesting concept to discuss with all of you. Okay, now I have seen many students basically confused in the concept of direction cosine and direction ratio, right? I don't know why it's happened every time. Direction ratio and cosines. Okay, so what is the actually meaning of this? So direction ratio is basically given as DCs and direction ratio is basically given as DR. Okay, now I will explain this very simple. Okay, so let us say we have a 3D coordinate space. Okay, this is a x-axis, this is a y-axis, and this is a z-axis. Okay, so we are following the right hand system. Okay, so this is basically the 3D vectors coordinate space. Okay, so we have over here. Now any point in this 3D space we can given as point P can be given as x comma y comma z. Right. So if I join the origin with this particular point, we are basically going to get a position vector OP. Right. So this position vector OP in a 3D space can be easily written as xi cap plus yj cap plus zk cap. Right. Now if I try to find out what is the unit vector along the OP vector, so I will just divide it by the modulus of it. Right. I'll just divide this vector by the modulus of this particular vector. Right. That is going to be divided by square root of x square plus y square plus z square. Right. Now interesting thing is to know that the unit vector that you make after you are making this unit vector, so there is a unit vector OP vector, right, which is in the direction of OP vector. Right. So once you get the unit vector OP, then if you just try to resolve the vectors along the three coordinates, so if you just try to take the projection of the vector along the x-axis, along the y-axis and the z-axis, these are nothing but these are the direction cosines. Right. So let us say this particular vector makes an angle alpha with the x-axis, beta with the y-axis, and gamma with the z-axis. Okay, so this is a 3D plane. Try to understand this. Okay, this is a 3D axis. So if it is a vector OP, then if it is a vector OP, I hope my pen is visible to all of you. Okay, so if this is a vector OP, the angle which is a vector, the axis are making with this vector is basically the given angle alpha, beta, and gamma with the corresponding respective axes. Okay, is it clear? Fine. Okay, so now the particular part which are getting with the corresponding I, J, and K are those ratios are basically the direction ratio. So I can direction cosines. Okay, so the direction cosines I can mention easily as x upon square root of x square plus y square plus z square, comma y divided by square root of this part, comma z divided by square root of this part. Okay, so that will generate me the direction cosines. Okay, the direction cosines are basically useful for denoting the direction along this particular vector. Okay, so it's not a difficult concept, it's just a simple concept that it is basically a unit vector. Okay, now interesting part is that we also write the direction cosine as this is cos alpha, this is basically cos beta, and this is basically cos gamma. So if you just try to find out what is the cos alpha over here, you just need to project this vector onto this x-axis and take a perpendicular, you will get this particular line. is basically equal to cos alpha if the unit vector is of unit modulus. Okay, so this particular value will be basically equal to cos alpha, right? So the cos alpha is the direction cosines. Okay, so direction cosines are basically the projection of that particular unit vector onto the x, y, and z axis, right? As simple as that. So once you do this, we'll basically get cos alpha, cos beta, and cos gamma, and therefore using this particular relation we can get a very important relation, that is cos square beta plus cos square alpha plus cos square gamma is basically equal to 1. Got it? Is it clear? Right. So once this particular part is clear, so direction ratios are what? The direction ratios are nothing but it is basically a sum multiple times of direction cosines. Okay, so that is how you can easily remember this part. Okay, so it's just some multiple times of, or it's some factor times of the direction cosines. Okay, I hope this part is simple and clear enough, right? So I was able to make this part of direction cosine and direction ratio very simple to all of you, right? So please don't forget this important relation. Okay, this is very important. Okay, it will actually help you to solve problems. Okay, so we will see some problems where we basically apply this particular concept. Okay. Alright, so we have a very simple problem for all of us. Now, if the vectors are given parallel, then their given corresponding I cap, j cap, and k cap are basically in a same ratio. Okay, so if you just apply the same ratio over here, so that is going to be equal to 3. So here from here you will get basically p is basically equal to minus of 1 by 3, right? So if you just use p is equal to minus of 1 by 3, you will get this particular set of vectors are parallel, right? So for parallel vector, we know that this is basically, so we will have for parallel vector we will have sin theta is equal to 0, right? So for parallel vector you just need to compare the ratio or keep the ratio in the common constant. Okay, so let us say we have two vectors parallel with the corresponding relation a1 I cap plus b1 j cap and so on. Okay, so their corresponding I cap, j cap, and k cap part are basically going to be in the common ratio. Okay, so that is how, what is the concept of the collinear vector or parallel vector. Collinear vector also means the same thing. Okay, so if you just apply this, you will get the value of p. It was a 1 marker problem. Okay, so if you just do all this part correctly, now I am not showing the solution how you will write it up. I am leaving this for you to understand and how to write it up. Okay, so this is something that you can definitely try to do this, and if you get the answer, let me know in the comment section. Okay, if you have any query, please let me know. Please let me know in the live chat. Okay, so now with this part, I actually wanted to take up this problem of the direction cosines to understand. Okay, so we have this vector A, which is basically having some magnitude. Okay, so I have a vector A which is given magnitude as 5 root 2, right? So this is a magnitude of the vector, and it is making x-axis. The angle is pi by 4, the angle is pi by 2 to the y-axis, and the angle is theta with the z-axis. So you just need to apply the direction cosine formula, that is basically cos square alpha plus cos square beta. Now in this case the cos square gamma, the gamma is replaced as theta. Okay, the angle with the vector makes with the z-axis given as gamma, so we just see we have to use this theta. So we have to use our theta over here, that is basically equal to 1, right? And we have information about the cos alpha, cos beta, right? Cos beta is basically equal to 0, right? And cos alpha is basically equal to 1 upon root 2 whole square of it, right? So that is basically going to give me cos square theta. So plus of cos square theta is basically equal to 1. So from here I'll get cos square theta is basically equal to 1 minus 1 by 2, that is going to be 1 by 2, right? So cos theta is basically again going to be equal to, so theta is going to be equal to pi by 4, that is the acute angle, right? So cos theta we get it is 1 by root 2, and we need the acute angle, so acute angle is going to be equal to pi by 4, right? So this is how we have to basically solve this problem. So we have a given vector with a given angle alpha, beta, and it is mentioned in the problem that this gamma is basically equal to theta, right? So we found out what is theta, right? So this is how we have to basically solve the problem. Okay, now again I'm not showing the step-by-step calculations, I'm leaving that up to you. Okay, please let me know if you have any query. The answer we are getting is theta is basically equal to pi upon 4. Okay, it's just by simply using the direction cosine formula. So we just use the direction cosine formula, we are basically going to get this part. Okay, so I hope this thing is clear. It's simple and straightforward, right? Okay, please let me know if you have any query. Okay, now I am leaving this part of the calculations up to you. So the way you are basically representing this part will actually help you to understand the examiner in the problem also. Okay, so please make sure that you write the entire things properly and clearly. Okay, so we know this particular relation exists. Okay, so by direction cosine relation. Okay, so please write this part clearly. Okay, so by relation we have already found out. Okay, so I'm not mentioning it over here, so please do the needful. Okay, so we already have that particular expression. Okay, so by using this particular expression. Okay, right, so this is fine, this is clear, right? Okay, now I have one more problem for all of you. Okay, this is a problem that I want all of you to solve as a homework, and let me know in the comment section. Okay, please let me know in the comment section. I will be checking the comments, okay? And the top students who are basically solving this problem in the comment section will definitely get some bonus, okay? So make sure that you are basically be the first among the one to comment in the with the answer, okay? So if you are commenting the right answer very fast, then you are definitely going to have some bonus tips, okay? So don't miss out on this particular opportunity. This is a very golden opportunity, and you might also have an opportunity to directly come on for a one-to-one live interaction, okay? So that is what we can also approach. So definitely don't forget to comment, and if this particular lecture is beneficial to all of you, please don't forget to like and subscribe, and please also try to share this particular content. This is a free content which is basically done for all of you. So your friends who are also preparing for the CBSE examination, please share with your friends also, okay? Like, it's not like keeping it limited to yourself. It's like you share it. The more you share, the more better you become, okay? So please help us also to share this word of mouth with the entire world, that these free lectures what we are actually providing, and we are trying to help out the entire community who are basically preparing for your CBSE examination for your maths part, okay? So the entire fear of maths is going to be removed by watching these particular live lectures, okay? So, and if this content is meaningful for your life, please don't forget to hit the subscribe button, and also click on the bell icon to never miss out any notification, okay? So we are basically having some live classes every day, you can see. So with these live classes, you are basically going to revise the entire syllabus of the CBSE examinations, okay? So with this, let us end our session over here. So we had discussed a lot of things about vectors. So I hope you will remember these parts of the calculations and solutions. So with this, let us end our session over here. Please don't forget to like the video and share it among your friends, okay? Thank you so much.